Now combination of capacitors. So capacitors are connected in series as well as parallel. So here first we will discuss the combination of capacitors in series. When the capacitors are connected with supply as shown in the figure, then that is called the series combination of capacitor. Here, suppose capacitance of these two capacitors connected in series are C1 and C2 and are connected with the battery of V volt. Now here, always remember this thing, when capacitors are connected in series, the charge on each capacitor that will be the same one. Charge on each capacitor that will be same one. So C1, C2 are the capacitance. Charge on each capacitor, that is QQ. Obviously, the potential difference across each capacitor will be different one, and suppose it is V1 and V2. Now, between these two ends, the supply voltage, that is V volt, and here across capacitors, the potential differences are V1 and V2. So we can write the potential difference V, that is equal to V1 plus V2. But C, that is Q by V, so V, that is Q by C. As per that, we can write the potential difference across first capacitor, that is Q by C1, and potential difference across the second capacitor V2, that is Q by C2. So now we can write V, that is equal to Q by C1 plus Q by C2. Now take Q common and take it on left hand side. So we can write V by Q, that is equal to 1 upon C1 plus 1 upon C2. Now, suppose the equivalent capacitance of this combination, that is C, then C, that is Q by V, but here we have V by Q, so that V by Q, that we can write 1 upon C. So resultantly we will get 1 upon C, that is 1 upon C1 plus 1 upon C2. It implies that suppose we have the series combination of n capacitors having capacitances C1, C2, C3, C4 up to Cn. Then the resultant or equivalent capacitance that we can give by the equation 1 upon C equal to 1 upon C1 plus 1 upon C2 up to 1 upon Cn. And here the resultant, or we can say equivalent capacitance obtained, that will be less than the smallest one connected in the combination. Now, if all the capacitors are with same value, and that is C dash, then the resultant or equivalent capacitance will be C dash by N. Clear to all of you? Now, parallel combination of capacitors. See, when capacitors are connected with battery as shown in the figure, then we can say that is the parallel combination of capacitor. Okay? And now always remember this thing, in the parallel combination of capacitors, the potential difference across each capacitor, that is same one. Suppose here total Q amount of charge is supplied by the battery, then that charge will be distributed on these two capacitors. Suppose charge on the first capacitor having capacitance C1 is Q1, and charge on second capacitor having capacitance C2, that is Q2. Now here total amount of charge supplied by the source, that is Q, and it is distributed in two parts, Q1 and Q2. So simply we can write the equation Q, that is Q1 plus Q2. Now potential difference across each capacitor, that is same one. So we have the equation C, that is Q by V. So we can write Q equal to CV. So here for first capacitor we can write Q1, that is equal to C1V. For second one we can write Q2 equal to C2V. So resultantly we can write Q equal to V into C1 plus C2. Now take V on left hand side. So Q by V, that is equal to C1 plus C2. Suppose here the equivalent capacitance of this combination, that is C. Then Q by V resultantly that we can say equal to C. So C equal to C1 plus C2. Suppose we have the parallel combination of n capacitors having capacitances C1, C2, C3 up to Cn. Then the resultant or equivalent capacitance that we can give by C equal to C1 plus C2 plus C3 up to Cn. If all the capacitors are with same capacitance, suppose we write C1 equal to C2 up to Cn, and that is equal to C dash, then resultant or equivalent capacitance that will be N C dash. Clear to all of you? Now in parallel combination of capacitors, the resultant capacitance that will be greater than the largest one connected in combination. Clear?